Would you believe the last video I put up on this circuit, I received an email within 20 minutes that I'm using supercapacitors on the power rails. I don't care. I'll take them out if that'll make everybody happy. It's not a prerequisite to have those capacitors in there. It makes it a lot easier to initially get it into oscillation, but they're not supercapacitors. Here you can see on this fellow right here, he's in operation. You can see that by the indicator LED. There is no capacity on that board at all. And you can see here, again, you can't tell anything on the indicator LED, and that capacity is gone also. So don't be sending me the nasty emails that I'm fooling around here. I'm trying my best to show you that this is something that does work and that there's no collusion or misrepresentation taking place. Okay, what I'm going to be using is a Booten RF millivoltmeter, a model 92 Bravo David, and I'm going to be using the regular Booten probe, and I have a little piece of wire stuck in the end of it and a little tip on the end so I don't mistakenly touch anything. Now what I'm going to do first is I'm going to carefully try to get in here so that I can hold this millivoltmeter up in the air there. Okay, I've got it set on 10 millivolts maximum. Okay, and we're reading 2.9 millivolts. This is stuck into the air here. I'm just holding it in the air. You definitely will see, you're definitely going to see something if it's around here. Let's get it over here on this wire. And this wire says 8 millivolts. This is coming back from the power rail. Let me get it back up to 100 so I don't blow my meter up. Okay, let's take and probe this thing now and see. We're on the 100 millivolt scale maximum. Let's lay this down here along this counterpoise piece of wire. You see we have no indication. Let's go over here and lay it next to the power rail. You see we have no indication. You also see that we're still sitting at the nice no current range. Now one thing you're going to notice here, and I'll show this to you, this coil of wire is actually picking up energy from this running system. Let me lay the probe down here on this coil, and you're going to see 27 millivolts. Now it does not affect that. It has not killed the oscillation. It's just merely because that wire is coiled laying there, and as I move up here you see it's not present. Okay, so now I want to take and probe right here, right at the output of this exciter and the input to that 1000 ohm resistor. Let me get in a little closer, and we're looking at about 24 millivolts. And let's probe then on this side of that 1000 ohm resistor that's driving this aluminum plate, and you see that we're reading 93 millivolts. So let's go up here now and place this on this one, and we have 58, and I want to sneak in underneath here, right here, and we have 44. Now if I probe this coil right here, you're going to see, well, I better probe right here, that's the first place, laying it right across the power rails. You see this guy's in operation quite strongly, so if I lay it right here at the power rails, you see we have 23. But if I get over here on this coil, the L3 coil, just lay it right there beside the coil, you see no energy. So if I get over here, you know, right close to where it's coming off of that aluminum block, you're going to see, you know, a reading of 20 some. And so Here, if we take a look at this L3, right here at this end, we're looking at 19. And we're still at 0, 0. So, what does that tell us? Well, it tells us for sure that there's no external energy coming in here in any of these wires that's feeding this circuit. Besides that, this particular circuit here does not have two leads going to it from any power source. The only two-leaded power source is right here to this exciter, which, like I say, is barely running. Compared to this fellow here, we've got 24 on the output side of L2, and if we look right here on this guy, we've got 41. So you can see that there's a definite difference in output from the two exciters.